So I presented last year a talk that would say how to survive with large monorepos in Gerrit. But we improved because before we were just surviving, and now we are fighting, and we won some battles. Not all the battles, but we won some of them. So first of all, just a recap of what I presented last year. So when you have a repo and when you define a big repo, it's not just one dimension. People say, I have a big repo, it's 40 gigabytes. That's just one dimension. There are many dimensions of a repo. And you can be big in different ways. You could have a lot of refs. So you could have, let's say, 100 megabytes repo with the 10 million refs. That's big, because we'll see has some consequences. You could have a lot of objects. And as I said, other consequences. Maybe you say, oh, I got just one ref, but 40 million objects. It's big in a different way, with different problems. And overall, let's say I define a big repo as a kind of three-dimensional space. You can have number of refs, number of objects, and this space. And there is relationship between them. They are not completely independent, right? But they are different dimensions. It's important what you're talking about. Because many times with customers, they say, I have a big repo, can I get LFS? Say, let's understand what does it mean big for you, because maybe LFS is not the right answer. Or maybe it is, I don't know. We need to understand first. And in my experience, first you get the numbers. When you get numbers, then you make a decision. But you don't make a decision up front without knowing what's your problem. Okay, so typically a tool that I really like from GitHub is Git Sizer. Gives you some initial clue. And whenever you run Git Sizer, did you guys use Git Sizer on your repos? Yes? When you run Git Sizer, you see all those exclamation marks. That's not a good thing. It's not that Git Sizer is happy, but you should be really worried, right? And let's have a look what are some issues that are more specific to the way that Gerrit. And when you use a monorepo in Gerrit, you enter into a space that is very dangerous. So first of all, you have an incredible explosion of refs. They are the ref changes. They grow, and they never go down. Even when you merge a change, the ref is there. And in certain industries, you cannot legally remove a ref. Otherwise, the software you're developing is not suitable for production anymore. And if you do some examples, if you take, let's say, 100,000 changes and touchpad set per change is already 1.1 million refs. And 100,000 changes is not that much. To give you one example, on GitHub.io, we got 600,000. And Qualcomm, they got over 4 million. 4 million changes, 50 patches per change is a lot. Yeah? And then you got the Gerrit-specific issues that because you keep the changes always there, abandoning doesn't help, right? And even if you abandon a change, the change is still there and occupies space. So some of the customers, they were showing us the growth of the repo they've got, and they say, how can I get it down? I say, can you remove refs? No. No way. It will go up. It will explode. And unless you do something, we do something, Gerrit does something for making it more scalable. And that's why we invested 12 months in that. So there are some Gerrit-specific issues as well. That is, if you use Monorepo, of course, all the people, they're working on the same repo, and all those changes, instead of being spread across multiple repos, they get concentrated. And here again, unfortunately, on GerritHub.io, we don't hit those problems so much, but our customers, they do. Because on GitHub, we have got 45,000 projects. We've got 600,000 changes, but spread across 40,000 projects. So it means this project doesn't have so many changes. But if you have a Gerrit repo, 1 and 600,000 changes, then it makes a big difference. An example is Chromium. If you go to Chromium Review, they've got 500,000 changes, 2.5 million refs, 42 million objects, and 60 gigabytes. Okay, so if you want to see what we focused on this year, just go to gitenterprise.me. That's our blog. And we basically declare what we want to do this year. And let's start. So we started in January. So round 1, we hit the wall with the SHA-1 CD. How many of you guys know what is SHA-1 CD? CD means for collision detection. So SHA-1, that is the algorithm that is used for hashing everything in Git. was basically crashed in 2017 by two guys, two from these company organizations, CWI, and 3 Google researchers, and they published their study in Shatter.io in 2017. And that was a year that I remember because it was the last hackathon that we did with Sean, because then he passed away. And then I say, okay, but how much JGit uses about SHA-1? Then you do this command, 272 points, where we refer to SHA-1. So actually, JGit doesn't use SHA-1 only for getting the ID of an object. It uses everywhere for all sorts of things that you say, wow, I didn't want that. And actually, that's the last hackathon that Sean participated. Sean is this one. Then next to Gustav, yeah. That Gustav is still in access, right, Gustav? Yeah. And basically, Sean presented the mitigation. It was put into SHA-1. But actually, I believe I was not really very, very focused on the changes that Sean did. But Sean, back in 2017, implemented the collision detection algorithm that was published by one of the people that discovered the collision detection, and introduced that change in 2017 in JGit. So what's the problem? So Sean did it already in a wise way that allows a kill switch, which is wise. Whenever you do some global change that you don't know really what's the impact, put a kill switch. Unfortunately, he rewrote all the SHA-1 in Java that is not as fast as the native one. So even when the collision detection is disabled, it was still using the Java code base. And of course, if you have a small repo, small data structure that wasn't creating too many problems, if you have a humongous data structure like packet refs, for instance, there was a very, very big problem. So if you wonder how many times Gerrit is reading packet refs, you will be amazed that every time that Gerrit needs to read an entry in cache, it's going to read the packet refs from the file system, which is surprising and scary as well at the same time, that every time it's going to calculate the SHA-1 with collision detection on that file. So we discovered that by testing, of course, and getting numbers. And the reason why JGit does that, because it wants to identify, this is a typo here, the packet ref ID, because it wanted to check if two files are the same. So here there is a difference. So this is getting worse when you run in HA, and we always run in HA, because of course you cannot trust the folder stats, and that was a big problem. So I just did a small change by saying, if we don't call SHA-1 CD, because we don't need to check if two files are the same, how faster can it go? Only 11 times faster. And that was a no-brainer. So it basically just made this simple one-liner change in JGit, and I asked the customer, can you run the same test? They said, what have you done? Gerrit is 11 times faster. I changed one line of code, yeah, but it was that line, that line. This improvement is not merged yet, but you're happy to review it, but it's there. So this was the first round, so in tackling number of refs, and that was a big problem. So even if you have a small repo, but a lot of refs, because you don't have my fix, because it's not been merged yet, you have this problem. Second round, commit priority queue, which was even more scary. So do you guys know what is a commit priority queue? So JGit, when navigates the repository, uses an object that's called revwalk. Revwalk is like bread and butter in the UK. Butter, they put butter everywhere. And JGit uses revwalk everywhere. And if you do the same grep, it's not 272, it's 1,500 times using revwalk. So, of course, if you do something good in revwalk, JGit is happy. If you do something bad and slow, and one thing that revwalk needs to do all the time is to sort the commit by date. And it's using a priority queue. And by my surprise, was using a homemade priority queue. I have no idea why. There was one of those commits that say, I'm doing a homemade priority queue. Reasons, I don't know. It wasn't written in the commit message. It was done by Sean, so I cannot ask Sean. So there is no way for me to understand why. But I said, but I can just use whatever the JVM gives me. JVM has a priority queue. And why is the priority queue in JGit is n square? You see that's the blue graph that you see there. The one that you get in the JVM is the green one, the n log n. As you can see, if n is small, they perform the same. But if you got maybe 10 million changes, this is just 10. Imagine you got 10 million, that will be where Tony is. Imagine that this curve continues where Tony is. So the curve up goes, let's say, to the shard on the top. The other is still touching Tony's hair, right? So there is a big difference between the two. This one, I'm not sure if this is merged or not, but it's merged. This one is merged. So if you upgrade to the latest version of JGit, you got this one. This has impacted the number of objects, because the more objects you have to sort, the more you're spending with that. And the third one is reachability check, because whenever you do replication, whenever you do a push, right, JGit is paranoid, because Git is paranoid. Yeah? When you do peer-to-peer, you always want to check that the other guy is not malicious, and whatever is given to you is not malicious SHA-1 and point nowhere. So the client and the server, they do reachability check all the time. And unfortunately, let me go there, it was checking reachability even the stuff that was advertised. So imagine when two Git, they communicate together, imagine that both of them, they got 40 million refs. It's a lot to check, right? 40 million, right? I got 40 million refs. I talk to Tony and say, I got 40 million refs. How many refs do you have? You need to say 40 millions. 40 millions. And then we were doing reachability check 40 million times, both of us. Even if they were the tip. So if he's telling me that we have the same ref, why do I need to do reachability check for all of them? So again, a couple lines of code, massive difference. So, and all these improvements then being encapsulated into the replication, pull replication plugin. And Marcin is going to show how you can turn minutes of replication to milliseconds of replication, because the difference is big, it's huge. And this was impacted, of course, number of objects, and you've got 40 million objects, of course, occupy more space. And this is not the end. I'm sure that the more we dig, the more we will find. But the good thing is that we are digging, and we are finding, and we're making JGit faster. Not just JGit, but Gerrit as well. But this will impact all the ecosystem on top of JGit, not just Gerrit, every other application.